Here's an algebra problem for us to try. So we have to find the area of this purple section here. Now we have some measurements, we have some variables, we have x over here, this measurement is x, and we have 4x is this whole thing over here. Let's forget about that for now. How would you find the area of that purple thing if there were just numbers there instead of variables? So let's look at an example. I just made up an example here like this. Let's say you had a big purple rectangle and you want to find the area of this purple shape here. So what you have to do is find the area of the whole thing, So you find the area of the whole thing, and then you have to subtract. You want to subtract the smaller rectangle. So basically what you have to do is find the area of the big rectangle, so length times width, and then subtract the small rectangle, so length times width, and that will give you the area of this purple thing. So in this example, we only have numbers here. I just made it up. So the area is going to be just 13 times 10 for the big rectangle, minus the area of the small rectangle, 5 times 4. So it'll just be 130 minus 20, which is 110 centimeters squared. Let's pretend it's centimeters squared. So that's how you would do it if you have no variables. But in this case, it's not as simple because we have some algebra, we have some letters here, some variables. Okay, so what is the area of the purple thing, the purple shape? Well, it's the area of the big rectangle minus the area of the small rectangle. So we start with just very generally speaking, this is what it is. Now, how do we find the area of rectangles? Well, the area of rectangle is length times width minus length times width. So I use a big L and a big W for the big rectangle and a small L, a small W for the small rectangle. Let's go back up here and let's find all these measurements. Okay, what is the big length? What is the big length? Well, it's 4x. This whole thing is 4x. So the length, 4x. Okay, we got that part. What is the width? So the width is this thing right here. This is the width of the big rectangle from here to here. So let me just go, it's all of this. So it's 2 plus x plus 2. One more time. So it's 2 plus x plus 2. So that's the width of the big rectangle. 2 plus x plus 2. And if we simplify that, well, 2 plus 2 is 4. And x. So we add the like terms, 2 and 2, we can add together. So we simplify to x plus 4. So now we know the big width and the big length. Now let's move on to the small one. So what is the width of the small one is x. It's easy. It's x. Well, what is the width of the big one? What is the width of the big one? Well, let's pretend. Well, we know that from here to here, we know all of this is 4x, but we have to take away 2. So if I take away 2, now it almost looks like what I want, but I have to take this 2 away also. So it's going to be 4x minus 2 minus 2. So the width of the small one, or no, let's say the length of the small one is 4x minus 2 minus 2. That's 4x minus 4. Negative 2 minus 2, or minus 2 minus 2 is minus 4. And the width is just x. We don't have to do anything for that. So now we have all our terms, and we can just plug them into the equation here. So let's look. The big L is 4x. So it's 4x times x plus 4. 4x times x plus 4. And then 4x minus 4 times x, but I'll say width times length instead of length times width, just so I have the x in front here. So I'm multiplying those two together. That's it. Now we're almost done. We have to use the distributive property. So 4x times x, 4x times x. Well, x times x is it's a repeated multiplication. That's x squared. 4x times 4 is 16x. Minus 4x squared. So minus x times 4x is minus 4x squared, and minus times a minus is a plus. 4x. And now we're almost done. Simplify, so I put the like terms together. Here I notice I have x squared minus 4x squared, and I have 16x and 4x. Those are like terms, so I can put them together. 4x squared minus 4x squared, that's going to be 0. 16x plus 4x, so these two guys cancel out. 4x squared minus 4x squared is 0. 16x plus 4x is 20x, and that's the answer. So that's the answer for this one. And now I'll have another one for you to try. I'm going to try this one. It's very, very similar. So try it, press pause, try it, and then I'll give you the answer. Okay, are you ready for the answer? You pressed pause, here comes the answer. So same thing, area of big minus area of small, length times width. So we have to find the length. 7x is given. The width is 3 plus x plus 3, very similar. And here we have to subtract 3 on each side. And the width is 2x. So plug all that back in. And it's very similar to the previous one. How did you do on this problem?